In this lesson, we're going to talk about the rules or the sign rules for multiplying real numbers. Now, ultimately, your sign rules are things that you have to have memorized. You can't think through the reasoning and the rationale behind them every time you do them. Similar to your times tables. At first, when you're learning how to multiply, say you're learning how to multiply, gosh, it does that every time, 3 times 4, somebody might walk you through, okay, well, that is 3, 4 times. And so you might have these like 4 groups of 3, and then you would count up all the dots in there and you would see that that was 12. And when you're first learning how to multiply, that's totally appropriate. And in fact, it's a really good thing to do because it teaches you what multiplication is. But you can't go on doing your math that way. Eventually, you just need to memorize 3 times 4 is 12 so that you're not thinking really hard about it every time you do it. And that's where things like flashcard games and I remember playing all sorts of games in elementary school that were just geared towards memorizing and try to make memorizing them a little bit more fun. So in this lesson, we're going to go through where our rules for sign numbers come from, and then ultimately you just need to memorize the rules. But it's good to have them grounded. So remember what multiplication is, and I kind of just alluded to that. If you have something like 3 times 4, what that means is 3 4 times. Or if you use that commutative property and switch it around, it could be 4 3 times. And what it means is you have 3 plus 3 plus 3 plus 3. That's what you're looking at. That's what multiplication is. It's a shortcut for repeated addition. And then you can fall back on your addition skills. Well, 3 plus 3 is 6, plus 3 is 9, plus 3 more is 12. Okay, now this actually also works for multiplying with negatives. So assume for a moment I had negative 3 times 4. Okay, so math is consistent. Remember, math is consistent, so definitions don't change, although sometimes they run out of meaning and we have to rethink them, which is what's going to happen in this lesson. But multiplication is what multiplication is. So I have negative 3 plus negative 3 plus negative 3 plus negative 3. And this is another great opportunity for seeing how math builds. And so what we're looking at here is using what we've already covered about adding the real numbers, and now we're taking that next step and expanding it to multiplication. So negative 3 plus negative 3 plus negative 3 plus negative 3. If you wanted to put that on the number line, you'd go left 3, then left 3 again, then left 3 again, then left 3 again, and you would be up to negative 12. And what we want to look for here is some kind of pattern. Oh, so I'm going to do another one. Let's do negative 4 times 5. Okay, so that would be negative 4 plus negative 4 plus negative 4 plus negative 4. 1, 2, 3, 4 plus negative 4. And then you can see that's negative 4 5 times, and that would give us negative 20. Now, what if you have the negative on the other side? What if you had 6 times negative 2? Well, remember that multiplication is commutative. That is one of our properties of numbers. You can switch the order of multiplication. So that would be the same as negative 2 times 6. And now we can engage that definition. So we have negative 2 plus negative 2 plus negative 2 plus negative, that's a negative. How many do I have all 6 there? 1, 2, 3, 4, 5, 6. And that would add up to negative 12. So what you might notice, and you do want to look for this pattern. So what you might notice is that when you multiply a negative number times a positive number, or unlike signs, you can basically multiply the two integers and the answer will be negative. So nothing changes about the multiplication facts that you've already got memorized, except that now when you have opposite signs, so one of the numbers is negative and the other number is positive, and it doesn't matter what order they're in, the answer is negative. So it's good to see where that comes from, but ultimately you just need to know that a negative times a positive or opposite signs, the product of opposite signs is going to give you a negative. Now, here's where it starts to break down a little bit and we need to look for a different kind of pattern. What about something like -3 times -2? So now we have a negative in both positions, and I can't write out a negative number of times. In fact, even saying it sounds a little bit unhinged, okay? So I could take -3 and I could do it 2 times, but how do I do -3 and do it a -2 times? Like, well, where am I going to write on my page? I'm going to like sink into my tablet. I don't know what we're doing. So what we're going to do to establish what happens when you multiply two negative numbers together is we're going to look for a pattern. Okay, because we know math is consistent. We know numbers behave in predictable ways. If you do predictable things to the numbers, then whatever happens is also going to be predictable and follow a pattern. So I used to, when I taught this in, usually it was about like 7th grade was the first time we would introduce this. It might have been like pre-algebra, maybe 8th grade. But I would try to work through this and help students see where these numbers come from. And sometimes in the rush to get through all of everything, like a teacher might just give you the rule and say, here's the rule, and nobody's ever showed you where it comes from or why it's reasonable. So watch what we're going to do here. We'll do the -3 times -2. So let's do -3, and I'm going to start with, say, 4. Okay, now we've already addressed that. Is that actually the one we did? It is the one we did. -3 times 4 we know is -12. And we've already established that if you're multiplying unlike signs, that the answer is going to be negative. So what I'm going to do is change this value, change that positive value. That's the one that makes sense. So -3 times 3 would be -3 plus -3 plus -3, which would give me -9. And then what I want you to watch is the pattern that's happening here on the right. So again, what I'm doing is I'm changing this column by 1 every time, and we want to see what happens in that right-hand column. So -3 times 2, well, 3 times 2 is 6, and since they're opposite signs, it'll be -6. And we'll do another one. -3 times 1, well, that's just -3 one time, or just -3. Now we should be able to start seeing a pattern. Here's what I'm changing, and I'm going down by 1 each time. Each time I do that, this value out on the right-hand side is increasing by 3. If you picture that on the number line. -12, to move from -12 to -9, we would move 3 units. To move from -9 to -6, we're moving 3 units. To move from -6 to -3, we're moving 3 units. Let's do -3 times 0. Well, anything 0 times is 0, and that pattern continues. So there's no reason to think that our pattern would be broken. Okay, I'll let that kind of sink in. So we have a very well established pattern of what we see happening. So if I follow this pattern, 4, 3, 2, 1, 0, the next number would be -3 times -1. And if this pattern holds, then it is reasonable to conclude that this pattern over here will also hold. So I'm going to increase by 3 each time. So increase 0 plus 3 is 3. And now all of a sudden the product is positive. And I can keep going with this pattern. So -3 times -2 would be +6. -3 times -3 would be +9. And so what we've got there is when the signs are different, the product was negative. When the signs are the same, the product becomes positive. So a negative times a negative actually gives you a positive. So you're like, well, that's wonderful. How do I know that that is something that would happen all of the time? Well, let's do another example. Like we don't know if it's going to happen all the time. So let's do 4 times 4. -4 times 4. So we established before, negative 4 times 4 is negative 4 plus negative 4 plus negative 4 plus negative 4, which is negative 16. And again, that's the product will be negative. And now we'll carry on this pattern. So I'm going to decrease that. And that is negative 12, because you're going to add the negative 4 in 3 times. Decreasing again. So now we have negative 4 times 2. Well, negative 4 plus negative 4 is negative 8. Negative 4 times 1, that's just negative 4 one time. Negative 4 times 0 is 0. So let's stop. Well, we'll kind of write the next one in. Okay, so I'm doing the same thing where I'm establishing a pattern. I can see exactly what I'm changing and how I'm changing it. And we want to look over here and see, okay, what's the pattern that's being established? Well, in this case, I'm adding 4 each time. So negative 16 is way out here on my number line. To get to negative 12, I would move 4 units. To get to negative 8, I'm moving 4 units. To get to negative 4, 4 more units. To get to 0, 4 more units, which stands to reason that the next one will also send us 4 units to the right. There's no should break at all. And then we could keep going. And then what we notice is that now we're back into that positive territory. So you're welcome to kind of go through this. It's not a proof. When you take geometry, you'll talk about like what a proof is. And this definitely is not a proof. People could ask some questions and say, well, this example doesn't show this. What we're doing here is we're making a reasonable argument and give you something concrete to look at so that these sign rules make sense. So here are the sign rules. And just like with your multiplication rules, ultimately, these are things you just need to know. So we already mentioned this one. This is the commutative property that says that you can switch the order of your multiplication and it doesn't matter. Okay. Then we have this property here. This is called the identity property. And that means that multiplying anything by the number 1 does not change its value. Very, very important property for solving equations. Then we have this one. This is why 0 is my favorite number. Okay, followed closely by 1. 0 times anything is 0. That comes in really, really handy. And then let's get into the sign rules. These are the ones that are probably new. Any number, and we'll just say like a positive number and then times a negative. Okay. If you don't want to say like this number is negative and this is positive, we can say some number and then the opposite sign. Okay. For whatever the other number is going to result in a negative answer. If they are both negative, then the answer is positive. And remember with this, just as a reminder, when you don't see an operation, the implied operation right here is multiplication. So here's the big takeaway. Same sign, product is positive. Okay, so 3 times 4 is 12, and negative 3 times negative 4 is also 12. So if you have the same sign, 2 positives or 2 negatives, then your product will be positive. If you have opposite signs, the product is negative, and that would be like 3 times negative 4 or negative 3 times positive 4. Both of those would give you negative 12. Now, for a while, you're probably going to need to think really hard about these rules, because what a lot of my students get confused with is this. They'll say if you have negative 3 plus negative 4, that is negative 7. But negative 3 times negative 4 is positive 12. And a lot of my students will get those two rules kind of flip-flopped in their head. And the reason that happens is because they just don't practice them enough. Okay, it's not because they've never been told those rules. They just don't practice them enough. And so they end up getting confused with them. So you want to make sure that you are practicing with these sign number rules. Okay, I think that pretty much is the whole content of the lesson. I'm going to walk through just a couple of examples, and we'll do some that are a little bit different. So, what if you had the number 6, and then you had the variable negative x? Well, now they're opposite signs, so you have one positive and one negative, which means that the answer will be negative, and then you would just do the 6 times the x, and that would give you negative 6x. If you had, let's say, negative 1/4 times 4, okay, so a negative times a positive gives you a negative, and then 1/4 times 4, well, that's the same as 1/4 times 4 over 1, and then you just multiply straight across, so that's 4 over 4, which is 1. What if you had more than two things? So what if we had something like negative 4 times negative 2 times x? Well, we can go from left to right. So a negative times a negative, we know now, will give us a positive, and then 4 times 2 is 8, and then that is just 8x. You don't need the parentheses there, and they're not wrong, but they're also totally extra. What about this one? Negative 3 times 5 times negative y. So looking at this, we can go from left to right. Now, I probably wouldn't exactly approach this in a straight left to right format, but we have negative 3 times 5, which is negative 15. And then what I did there was I just kind of changed the multiplication symbol. It's not more right or wrong or anything. I'm just more comfortable with it. Now we have a negative times a negative, which will give us a positive, and we have 15 times y, which is just 15y. And we'll do one more. Oh, this is a good one. Let's do negative x squared. Okay, and then we'll do negative x cubed. So negative x squared, notice what's being squared. The parentheses are being squared. So we're going to take everything in the parentheses and multiply it together, and that includes the negative because the negative was in the parentheses. And now we know that a negative times a negative gives you a positive. X times x would give you x squared. Over here, we'd have 3 negatives. X times x, negative x times negative x, we just did that. That's x squared. And then now we've got to do a positive times a negative, which is a negative, and then x squared times x. Now this gets into like a power rule, but I'll just do a little bit of scratch work. X squared is x times x, and then we have another x, which is going to give us x to the third. So now what you might notice is this. If you have an even number of negatives, the final result is going to be positive. If you have an odd number of negatives, the final result will be, I think I said that, negative. And noticing patterns like that can really help. And that's why it's so important to practice. And what I was actually talking in my classes today about handling the math. Sometimes it's not about whether you understand the concept or not. You just need to handle it, and you need to do some problems and keep seeing it. So on that vein, I'm going to, on the next slide, put some practice problems up there, and then you can, as usual, go ahead and do them, and then we'll check them. Okay, here we go. Negative 6 times 8, 2 times negative 9, negative 4 times 15p, 5 times negative 2c, negative 3 all squared. That's how I'm indicating the presence of the parentheses. And then notice the difference between 5 and 6. This one is just negative 4 squared, so that one's driving at, do those parentheses make a difference? Negative 2 times negative 3 times negative 5, negative 4 times x times 12, 2x squared minus 4x when x is equal to negative 3, and negative 2x minus 5x when x is equal to 4. So go ahead, pause the video, try these out on your own, and then we'll look at them together. Okay, Okay, I'm going to try to finish this before 23 minutes, so I'm going to go super speed. The first one, -6 times 8. A negative times a positive is a negative, and so then it's just 6 times 8, which is 48. So the answer should be -48. Same as number 2, a positive times a negative is going to give you a negative, and then 2 times 9 is 18 for an answer of -18. For the next one, same situation. In fact, a bunch of these are the same situation. A negative times a positive is going to give you a negative. Then we would do 4 times 15. Now to do this, think about like minutes. You have like 4 15-minute segments would give you 1 hour, which is 60. And then that P is just being multiplied with it. That's just another multiplication. You just can't simplify it any further. So you would multiply the two number values there. Number 4 is similar, so 5 times -2c, well, we have opposite signs, so that'll be negative. 5 times 2 is 10, and all of that is being multiplied by c. Now, we just did one like this, -3 squared. What you're squaring is the parentheses, so it's -3 times -3, and now we know a negative times a negative is a +9. Now that is different from the one underneath it. In -4 squared, the squaring only goes with the 4, not with the negative. So the negative is not being squared. What we have there is 4 times 4 with the negative being brought down. So what this looks like is 4 times 4 is 16, and then the answer is negative. You could also think of that as a -4 times +16, which would give you that negative answer. So notice that the parentheses do make a difference. When you have the parentheses, you end up with a positive. When you do not, you end up with a negative. That is a massive and common mistake that, that all students make with their algebra. Next one, we have 3 different things going on. So we have -2 times -3 times -5. Well, a negative times a negative is a positive, giving me +6. +6 times -5, that'll give us negative, and 6 times 5 is 30. So we have -30. For the next one, we have -4 times x times 12, and what I'm going to do on this one is I'm going to use that the order doesn't matter, and I'm going to go ahead and switch the x and the 12 so that, and you don't have to do that, I'm just doing it because it puts them closer together. Now we have a negative times a positive, which we know will give us a negative, and then 4 times 12 is 48, so we have -48, and then the x is just still being multiplied there. And last 2 problems. These ones are substitutions, so we have 2x squared minus 4x when x is equal to -3. So we're going to go ahead and take out the x. We're going to plug in the -3. Now, fortunately, we just did this on the previous page there. So we did our 2 pages ago. I won't go back. -3 times -3 is +9. And then there's different ways you can think of this. I am going to pull my old algebra teacher out of the hat here. And remember, he never let us do subtraction. He made us do it as plus a negative. And what that does is it visually changes, so much for finishing in 23 minutes. I tried, guys. It changes that so that you can see a little bit more clearly that this is a negative times a negative. So on the left we have 18, and then we know a negative times a negative is going to give us a positive, which will be 12, and then 18 plus 12 is 30. And then the last one here, -2 times 4 minus 5 times 4. And I'm going to do the same thing with that one. It is a weird little step to change it to a plus negative, but while you're getting used to the signs, while you're getting used to these sign rules, it's actually a pretty nice way of seeing that that this is a negative number times a positive number. A lot of times when you don't do that, students will lose sight of the fact that it is a -5. So a negative times a positive is going to give us a negative. That's -8. And then we have the same thing over here, a negative times a positive is going to give us a negative 20, and then negative 8 plus negative 20 is negative 28. I think you can really see how the skills are starting to build, and we kind of breeze through some of the older concepts faster. Sorry I ran over. I really did try. And so there's multiplication of real numbers.